Hello everyone. Today I am talking about the basic fundamental introduction about organic spectroscopy and different types of spectroscopic techniques. Okay. So first of all we have to know what is spectroscopy and what is the definition for spectroscopy. So the word spectroscopy is derived from Greek. So it is a Greek Italian word. Okay. In spectroscopy entirely two different words are there. So first word is spectra, another word is scopy. In Greek, spectra means spectrum and scopy means study or measurement or movement. So simply study about spectrum is generally called as spectroscopy. So this is just a normal general information for spectroscopy, not a scientific definition. Okay, the study about spectrum is called as spectroscopy. This is a just normal information. Now what is the exact scientific definition? For spectroscopy, it is the interaction between an electromagnetic radiation EMR and matter. So for example, if we take an electromagnetic radiation and matter, whenever the electromagnetic radiation and matter will come to each other, they can give one output. Okay, that output is called as spectrum. So spectrum is nothing but the output of the interaction of, it is a result of output of two factors. What are they? First factor is electromagnetic radiation and second factor is matter. So and the interaction between electromagnetic radiation matter is generally called as spectroscopy. So this is the exact definition for spectroscopy. And another definition for spectroscopy I can write here, that is gathering the structural information about an organic compound. If I can pass through an electromagnetic radiation towards the unknown substance, what changes takes place? That is the spectroscopy. Okay, so there are two factors are there now. So first factor is electromagnetic radiation and second factor is matter. So electromagnetic radiation is nothing but light radiation. We already know that one, so I can discuss later. So now coming to matter. Okay, matter is anything, it has some mass and occupies some space. So in other cases is nothing but, the matter is nothing but an unknown substance. Matter is nothing but an unknown substance. This is sample holder now. So this is unknown substance. Unknown sample may be protein, peptide or any other organic substances. Okay, if I can take the unknown sample having consists of many of molecules. Okay, every molecule having energy, that energy is called as molecular energy. Okay, the unknown sample is consists of many of molecules. Many of molecules consists of many of atoms now. So every atom exhibit energy and every atom is present in molecule, that molecule also exhibit energy. So that's why every molecule having energy, that energy is called as molecular energy. Here one doubt is raised, that is how the molecule exhibit energy. Okay, how the molecule exhibit energy, that is how the sample exhibit energy, where from the energy coming to the sample is the question. Okay, so based on three factors, the sample exhibit energy. So what are they? First factor is electronic energy and second factor is vibrational energy and finally third factor is rotational energy. So electronic energy percent may be 10,000% it is, and vibration energy is 100% energy and rotation energy is 1% energy. Electronic energy is represented with EE and vibration energy is represented with VE and rotation energy is represented with RE. Whenever these three energy levels are insert in the molecule, that's why molecule exhibit energy. If I can pass an electromagnetic radiation towards the matter, unknown substance, there will be change in electron, there will be change in vibration, there will be change in rotational. So whenever these three energy levels are present in the molecule, that's a molecule exhibit energy. Okay, so finally instead of matter I can write molecular energy because of molecule exhibit energy. Why it exhibit energy? Because of these three factors. Okay, so finally molecular energy is a combination of three cases. What are they? Electronic energy, vibration energy and rotational energy. Okay, so one side is over. And coming to the next factor, it is a very important factor in spectroscopy. Okay, that is electromagnetic radiation. Electromagnetic radiation is represented with the EMR, electromagnetic radiation. So every light radiation, every electromagnetic radiation is in the form of energy. We already know that one. Okay, if I can take any type of radiation, it can travels in wave motion. Okay, so if I all type of radiations travels with the same velocity, they and no medium is required for their propagation. They can travels in vacuum also with a constant velocity. That velocity may be 3 into 10 to the power of 8 meter per second. This is the velocity of light. Okay, if I consider a nature having many of particles present in the nature, right? So every particle cannot act as a light. Only few particles can act as a light. What are they? The particle should exhibit charge and accelerated motion. Okay, so I can take an example. If I take a particle, so this particle having charge and accelerated motion. Okay, so because of charge, the particle create a negative field around the negative field around the particle. Okay, negative field around the particle. So due to presence of an electric field, automatically magnetic field also created automatically. Okay, if I take a particle, so due to charge they can create a negative field around the particle. So presence of electric field, automatically magnetic field also created automatically. So charge work is done. Okay, due to second factor. Coming to second factor, that is accelerated motion. So accelerated motion means moving nature, that is kinetic motion. So that's why the electric vector is travels in the wave nature. Because of accelerated motion, automatically magnetic field also travels opposite to the electric field vector. And this line is indicated with the capital E, and this dotted lines magnetic vector is indicated with the capital M. And these two vectors, electric vector and magnetic vector, both are perpendicular to each other and both are perpendicular to their direction of propagation. Finally it will give a energy. That energy is called as electromagnetic radiation. Okay, next electromagnetic radiation. So next point is electromagnetic radiation. Instead of electromagnetic radiation, I can write photon. I can write photon energy. It is represented with PE, photon energy. Why electromagnetic radiation exhibit energy? So because of electromagnetic radiation is made up of small size of packets, like here. Electromagnetic radiation is made up of small size of packets, and each packet having specific amount of energy, right? Okay, so each packet is called as photon, and that specific amount of energy is called as photon energy. So instead of electromagnetic radiation, I can write photon energy. So based on matter, instead of matter I can write molecular energy na. So same way instead of electromagnetic radiation I can write photon energy. So basing on molecular energy and photon energy, I can write another definition for spectroscopy, that is the interaction between photon energy and molecular energy. The interaction between photon energy and molecular energy is called as spectroscopy. This is a standard definition. For spectroscopy. It is from international standard textbooks. Okay, this is about the spectroscopy definition, the electromagnetic radiation and matter. So coming to the next one, that is if we take any type of unknown substances, every unknown sample having constant energy, so it never be varies. That energy may be 100 kilocalories. If I can take any unknown sample having molecular energy na, this energy may be constant, it never be varies. That energy may be 100 kilocalories. If I can pass an electromagnetic radiation, there is nothing but photon energy. If I can pass a photon energy towards the unknown sample means molecular energy, right? Okay, so it absorbs some amount of energy. If no passing energy, the energy will be constant. If I can pass energy, they can absorb some amount of energy, the energy level will be raised, that is 120 kilocalories. And after some time it emit or it loses some amount of energy towards the photon, it lost energy, that is 80 kilocalories. And these changes in the energy levels are captured by the detector work is it detects the changes in the molecular energy levels. So finally it is respond to give the corresponding graph. If I can pass UV light radiation, it can give UV spectra. If I can pass IR light radiation, it can give IR spectra. If I can pass NMR radiation, it can give NMR spectra. Okay, so changes in the molecular energy levels by the presence of only electromagnetic radiation, that is photon energy. Without application of photon energy, electromagnetic radiation, there is no changes in the molecular energy levels. So finally the whole spectroscopy concept is based on electromagnetic radiation. Without applicable of electromagnetic radiation, there is no change, there is no graph will be observed. So basing on spectroscopy, there are different types of spectroscopy techniques are there. So first technique is UV visible, and second technique is IR, and third technique is NMR spectroscopy, and fourth technique is mass. These four are the very important spectroscopic techniques. Okay, so if I can pass UV light radiation, there will be changes in electronic energy level, it will give UV spectra. Okay, if changes in vibration level, it can give IR spectra. If the changes in rotation level, it can give NMR spectra. And these three are the absorption spectroscopies. Okay, and what about mass? In mass, there is no formation there is no passing electromagnetic radiation. If I can bombard it with the 70 electron volts, it can lose one electron, it can give radical cation. There is no formation of electromagnetic radiation. Okay, so this is all about spectroscopy. So coming to next one, that is what is electromagnetic spectrum, very important in spectroscopy. So the electromagnetic spectrum is the arrangement of all type of electromagnetic radiation. Okay, we know cosmic rays, gamma rays, x-rays, visible IR, microwave, radio waves, TV waves, lots of rays we have to know. Okay, you already know that one. So that radiations arrangement are discussed to the electromagnetic spectrum, the arrangement of all type of radiations in order of their increasing wavelength or decreasing frequency. Okay, increasing wavelength or decreasing frequency is generally called as electromagnetic spectrum. So I can write here cosmic rays, gamma rays, x-rays, UV visible, IR, microwave, radio wave, TV waves. From left to right, the wavelength increases. From left to right, the wavelength increases. From left to right, the frequency decreases. From left to right, the energy decreases. So whenever the energy decreases, wavelength also increases and frequency decreases. So that's when from left to right, from top to bottom, energy decreases. So that's the wavelength increases. So here increases wavelength or decreasing frequency now. So that's why energy decreases, that's why wavelength increases from left to right, and frequency decreases. So this is about electromagnetic spectrum. So finally, spectrophotometer. So spectrophotometer is a device which record the which kind of spectrum they can give. Okay, so thank you everyone, thank you.